Chapter 14, Temperature and Heat Transfer. This lecture will help you understand thermal expansion. The extreme heat of a summer day causes the buckling of these railroad tracks. The gap in the roadway of a bridge is called an expansion joint. It allows the bridge to expand and contract. When stringing telephone lines between poles in the summer, it is advisable to allow the lines to A. Sag, B. Be taut, C. Be close to the ground, or D. Allow ample space for birds. The answer is A. Sag. Telephone lines are longer in a warm summer and shorter in a cold winter. Hence, they sag more on hot summer days than in winter. If the lines are not strung with enough sag in summer, they might contract too much and snap during the winter, especially when carrying ice. A nut heats a metal ring that has the same inner diameter as the diameter of the metal ball. When the ring is hot, the room temperature ball, A, fits into the hole as before, B, no longer fits in the hole, C, fits into the hole with more room to spare, or D, none of the above. Answer is C, fits in the hole with more room to spare. When the ring is heated, all parts expand. This means expansion of the inner and outer circumference, inner and outer diameter, width, you name it. The hole expands just as if it were solid metal. How about that? A bimetallic strip is a piece of brass and a piece of iron welded together. When the strip is heated, brass expands more than iron. When cooled, brass contracts more than iron. Due to this behavior, the strip bends as shown. Bimetallic strips have long been used in thermostats. When the bimetallic coil expands, the ball of liquid mercury rolls away from the electrical contacts and breaks the electrical circuit. When the coil contracts, the circuit is complete and the furnace turns back on. At some initial temperature, T sub 0, the rod in the picture has a length L sub 0. After heating it to a temperature T, it now has a new length, L. The new length is L equal L sub 0 plus delta L, where the change in length is given as delta L. The linear expansion formula is then the change in length delta L is equal to the coefficient of linear expansion of the material times the original length times the change in temperature. If the final temperature T is greater than the initial temperature T sub 0, then the bar expands and the change in length is positive. If the final temperature T is less than the initial temperature T sub 0, then the bar contracts and the change in length is negative. The chart shows the coefficient of linear expansion for various materials. A steel railroad rail is 40 feet long and 0 degree Fahrenheit. How much will expand when heated to 100 degrees Fahrenheit? The coefficient of linear expansion for steel is 6.5 times 10 to the minus 6 per degree Fahrenheit. The original length at 0 degrees Fahrenheit is 40 feet, and the temperature difference is 100 degrees. Our working equation is the linear expansion formula. Substituting what we know into the working equation yields an expansion of 0.31 inches. Not a lot of expansion, but if not properly accounted for, could result in disaster. Solids expand in width and thickness as well as length when heated. The area of a hole cut out of a metal sheet will expand in the same way as the surrounding material. We have formulas for the area expansion of material and the volume expansion of a material. The change in the area expansion is twice the coefficient of linear expansion of the material times the original area times the change in temperature. A positive change in area means the material expands. A negative change in area means the material contracts. The change in the volume expansion is 3 times the coefficient of linear expansion of material times the original volume times the change in temperature. A positive change in volume means the material expands. A negative change in volume means the material contracts. A section of concrete in a bridge support measures 6 meters by 12 meters by 30 meters and is at 38 degrees Celsius. What allowance for change in volume is necessary for a temperature drop to minus 15 degrees Celsius? The original volume is 2,160 cubic meters. The coefficient of linear expansion of concrete is 1.1 times 10 to the minus 5 per degree Celsius. The change in temperature is minus 53 degrees Celsius. The working equation is the volume expansion formula. Substituting what we know gives a volume contraction of 3.8 cubic meters. Liquids generally expand when heated and contract when cooled. Liquid thermometers are made using this principle. The heat from the substance causes the liquid in the bottom of the thermometer to expand. The liquid is then forced to rise up the tube. Liquids expand in volume. However, we cannot discuss linear expansion and area expansion of a liquid. The formula for volume expansion of liquids is the change in the volume of a liquid is equal to the coefficient of volume expansion for a liquid times the original volume times the change in temperature. The coefficient of volume expansion of various liquids is given in Appendix C. If petroleum at 0 degrees Celsius occupies 250 liters, what is its volume at 50 degrees Celsius? The coefficient of volume expansion of petroleum is 9.6 times 10 to the minus 4 per degree Celsius. The initial volume is 250 liters, and the change in temperature is 50 degrees Celsius. The basic equation is the volume expansion formula for liquids. Since the problem asks for the new volume, not the change in volume, we must add the original volume to the change in volume to get the working equation. With an expansion of 12 liters, the new volume is 262 liters. Water expands when it turns to ice. Ice has an open structured crystals resulting from strong bonds at certain angles that increase its volume. This makes ice less dense than water. Water is unusual in its expansion characteristics. Nearly all liquids are the densest at their lowest temperature before a change of phase to become solids. As the temperature drops, the molecular motion slows and the substance becomes denser. Water does not follow this general rule. Because of its unusual structural characteristics, water is most dense at 4 degrees Celsius instead of 0 degrees Celsius. A graph of its change in density with increase in temperature is shown in the figure. As ice melts and the water temperature slightly increased, there are still groups of molecules that have open crystallographic structure of ice, which is less dense than water. As the water is heated to 4 degrees Celsius, these groupings disappear and the water becomes denser. Above 4 degrees Celsius, water then expands normally as the temperature is raised. When a sample of 0 degrees Celsius water is heated, it first A. expands, B. contracts, C. remains unchanged, D. not enough information to tell. Answer is B. contracts. Ice water contracts due to the melting of microscopic slush crystals. Water continues to contract until it reaches a temperature of 4 degrees Celsius. With further increase in temperature beyond 4 degrees Celsius, water then expands. When a sample of 4 degrees Celsius water is cooled, it A. expands, B. contracts, C remains unchanged, or D not enough information. Answer is A, expands. Part of the water will crystallize and occupy more space. Interestingly, 4 degrees Celsius water will expand whenever heated or cooled. As water cools in winter, it becomes denser and sinks. Sinking continues until the entire pond is at 4 degrees Celsius. Then, as water at the surface is cooled further, it floats on top and can freeze. Once ice is formed, temperature lower than 4 degrees Celsius can extend down into the bottom of the pond.